How you are going to declare if the given one is in the second rule? When it is in the form of sin ax or hax form. Your rule 2, when q of x will be in the form of sin ax or cos ax. What you have to do here, your pi will be formula. Your pi formula will be 1 by f of d into q of x, which is equals to 1 by f of d. Either it will be in the form of sin ax or cos ax. Here you have to substitute. You're not going to substitute anything for the single d. You have to substitute your d square. It's equals to minus of a square. A square value with a negative. The minus is not inside. A minus of a square. You're going to substitute. And where if any single d is left, then you're going to rationalize that factor with the conjugate factor. Then again it will get changed to in the form of a
Ma'am,
d
can you
square.
just, ma'am, can you just,
Yeah,
ma'am,
yeah.
can you just repeat that part again? That if q,
Your pi is
I was
equals
noting
to
it down. Yes, ma'am.
1 by f of d into q of x is equals to 1 by f of d. It will be in the form of either sin ax
Yes, ma'am.
or cos ax. Here we have to substitute d square is equals to minus of a square. Here we are not going to substitute anything for the single d. After substituting your d square is equals to minus of a square, if any single d is going to left, we are going to do the rationalizing. Rationalizing means what? You are going to multiply and divide with a conjugate pairs. Where in the question if they have given as in a d cube is there, that d cube we can write as d square into d we can write. D power 4 can be represented as d square into d square. D power 5 it will be represented as d power 4 into d. Like this you have to substitute your, where d square you are going to substitute as a minus of a square. If any single d is left, I will say, if any single d is left, then you are going to multiply with the conjugate pairs. Here we cannot substitute anything for single d, as it will be imaginary, as it will be imaginary. Then what you're going to do, you're going to rationalize, means you're going to multiply. Then multiply numerator and denominator with conjugate factors. With conjugate factors. Conjugate factors means what? Yes, Aditya, conjugate factors means what?
Ma'am, the opposite. Ma'am, the opposite.
Yes.
Like
If it is in the
the
form
opposite,
of,
ma'am.
suppose if it is in the form of LD plus M is there, then you are going to multiply and divide with LD minus 1. It will be in the form of LD plus M, or it going to be in the form of LD minus M. If it is minus, then this will get changed with the plus. If it is minus, this will get changed with plus. If it is plus, minus. If it is minus and plus, opposite one you are going to. That is mean as conjugate factors. Again you have to substitute. Again substitute d square, it's equals to minus of a square in your denominator part. After that, your LD plus 1 or LD minus 1 will be there in the numerator also. Then whatever your q of x is given, either sin ax or cos ax, that you have to multiply to the each and every term of that bracket, where your d stands for differentiation d by dx, and 1 by d stands for integration. Remember that one. And after substituting it, your denominator part should not be become equals to 0. If this is the case for, this is the case where I
Ma'am,
should
1 by D stands for what, ma'am? Okay, ma'am.
1 by
Okay.
d stands for integration. This is the case 1 when your f of d or f of minus a square should not be equals to 0. It has to be not equals to 0. Is it clear? You are going to apply this procedure. If after substituting, if it is becoming 0,
Ma'am, so we basically just
shall I
multiply
raise
with the
it up? Huh?
conjugate. So we basically just multiply with conjugate, right?
Yes, multiply. Yeah, this is the
In this,
shortcut for the multiply.
okay.
Multiply numerator and denominator
Yes, ma'am.
with the conjugate of factors.
Yes, ma'am. Yes, ma'am.
Yes, it's copied. Shall we move for the second case?
Yes, ma'am.
Yeah. Your case 2, your case 2, after substituting, after substituting your f of minus of a square, if it is becoming a 0, then directly what you are going to do, if it is in the form of 1 divided by d square plus a square into sine ax, then you're going to write it is equals to minus x cos ax divided by 2a. If it is in the form of 1 divided by d square plus a square cos ax, which is equals to x sine ax divided by 2a. After substituting, if your denominator it's becoming it's equals to 0, when it's going to become a 0, when it is in this form d square plus a square form, in that case it will become it's equals to 0. If such thing is happening, then it will move to your case 2, where case 2 is saying that if I am in this form 1 by d square plus a square into sine ax, just simply write it is equals to minus x cos ax divided by a. Whatever the a value is there, you have to replace that a value over here. And your 1 by d square plus a square cos ax is, then you're going to represent your pi is equals to x sine ax divided by 2a under the case fails. This will go for the case fails. This is the condition for case fails. Where in your first rule, case fail was what? You're doing as in a multiplying numerator with respect to x and differentiating your denominator with respect to d, and after that you are substituting your every d is equals to a. Here it is not like that. If it is in the sin ax form, just you're going to write in this way. If it's in the cos ax form, just simply in this way. Yes, Aditya, any doubt over here? Aditya?